Welcome to Tech Innovation for those who have just joined us. Let's learn how to open new possibilities in mobility, fast charging devices, smart grid, and energy-efficient buildings from our first Keynote sessions speakers. Should you have any questions during the presentation, please type them in the Q&A feature on your screen. Your questions will be addressed during the panel discussion towards the end of this session. First, we have Dr. Doron Myersdorf from StoreDot, who will share his thoughts on how breakthrough technology can transform the future of energy storage and transport.
Okay, welcome everybody. We're going to talk today about extreme fast charging, electric vehicle battery technology for a sustainable future. I'm Doron Myersdorf, and I am the CEO and co-founder of StoreDot, which is a startup in Israel developing extreme fast charge solutions for the electric vehicle market. We are presenting a 50% reduction in charging time with the same energy density and the same price trajectory of the entire market. That would result 100 plus, even 150 miles in 5 minutes as the solution progresses over time. StoreDot is a startup in Israel with 120 employees. 35 of them are PhDs, with a very strong ecosystem of investors, including TDK, British Petroleum, Samsung, Mercedes, Daimler, and many others. The number one problem for adoption of electric vehicle is the range anxiety. And some people also add the charging anxiety. The idea that you may get stuck on the highway is a real problem for the adoption of electric vehicle. So StoreDot role is to provide a solution that would enable fast charging and later on also extreme energy density, XED, with a solution such as solid state. We are focused on the chemistry of the battery while we work with our partners on the design of the vehicle and the charging infrastructure. Throughout the years, we have demonstrated the technology in scooters, in drones, in power banks, but today we are only focused on the electric vehicle market, and we are shipping samples of 30 amp-hour cells that are optimized for 10-minute full charge of the vehicle. So we are looking at a market that is huge with a disruptive technology that is covered by over 100 patents that would provide this 50% reduction in the charging time. We are already shipping samples, and we are moving also to mass production inside the vehicle in 2024. We have these partnerships that would allow us to take this to market. Also our next generation, which is solid or hybrid solid solution that would enable 450 watt-hour per kilogram in 2028. And we have a very strong team that executes on this plan. So the market is huge because it's growing. This is like the number one revolution that is happening today in the marketplace is around electric vehicle. And this is also the connected vehicle, the shared mobility, the autonomous. All these are requiring fast charge in order for the revolution to take place. So even if we take out the heavy duty trucks and we take out the smaller cars, we are still looking at an over 100 billion of a serviceable market for batteries and 76 billion for extreme fast charge solutions. So as we look at the areas that are needed to be covered in order to bring such solution to the marketplace, we're looking at the active materials. These are nanoparticles of silicon. We are looking at the organic binders. We are looking at the electrode additives. These are all proprietary materials that we synthesize in-house here in our labs in Israel, and we take to production through our joint venture with Eve Energy in China. So we add organic additives to the electrolyte and additives to the anode and the cathode. And then we do a very unique formation process that supports specifically the fast charging capability. And we work on the entire system and cell design, including the charging station. So for example, we have recently shared through an open source our IP around boosting the charging current of the charging station, so everybody would enjoy fast charging, even if there is a limited infrastructure that does not give the sufficient current that the battery requires for the fast charge. So we are looking at 21 miles per minute at the charging station initially, and this is why we say 100 plus in 5 minutes. This is the way to mitigate the range anxiety. It's providing a solution, a psychological solution to the driver, that the experience in the charging station will be exactly like fueling, only without the fumes. So this enables a mass adoption of electric vehicles in the marketplace, mitigating the range anxiety. So we are already shipping samples, and our challenge is to reach at least 1,000 charge-discharge cycles of this battery before it starts deteriorating. This is what we are working on. We are currently at the 200 range, but like we've shown in our first generation, it takes about roughly 18 to 24 months to get from roughly 100 to 200 cycles to 1,000 cycles. But the methodology is such that you first demonstrate the capability of the energy density, which for us is 300 watt-hour per kilogram, and then gradually over time, you improve the cycle life, and we will reach, when we roll out the solution, it will have 1,000 charge-discharge cycles. So if you have 300 miles in each charge, the total range of the vehicle would be 300,000 miles, which is very sufficient. As we roll out the hybrid solid or the solid state solution in 2028, we are looking at 27 miles per minute. This is already looking at 450 watt-hour per kilogram at the cell level, which is a huge improvement, actually a 50% improvement over the 300 that we are targeting for 2024. But safety is a major concern, and everything that we do in the fast charge and also in the solid state and the design of the cell and the design of the system is to make sure that we are covering safety by design, meaning that everything that we do makes sure that there will never be any issues of dendrites or thermal runaway, an explosion, or any risk to the occupants of the vehicle due to safety issues. And this is inherent to the silicon solution that basically has much lower probability of dendrites, of these nails that might puncture a hole in the separator and create a thermal runaway. I spoke about our two partnerships, the joint venture on the manufacturing, as well as the relationship with the OEMs such as Daimler and others integrating the solution into the vehicle. This is key in taking such technology to the market, and we are very focused on the entire ecosystem, being the work with Daimler through the collaboration, or the work with BP, or with TDK, Samsung, Eve. All these are partners that are supporting us in taking this solution to the marketplace. Very strong management team. Our chairman came out of BP, he was the head of ventures. Myself, I was at Sandisk with the joint venture with Toshiba at the Yokkaichi facility. And also the rest of the team is highly experienced in taking startups into the market, public markets. And in terms of advisory board, we also cover the entire ecosystem from the Professor Orbach, who is the #1 electrochemist society head in the world. Also, Joseph Wailicki, who is the head of Johnson Control, Clarius battery, lithium-ion manufacturing, and also Roy Williamson from BP, and the rest also supporting us in taking StoreDot into the next level, which is also looking at the public markets. So in terms of our goal, we are looking at $80 per kilowatt hour in 2024, with revenues of 2.5 billion in 2028, also EBITDA of 20% plus margins. So these are our targets for the medium term. So thank you very much. This is our presentation, and hopefully we'll get to see each other very soon.
Following Dr. Doron's insightful presentation, Cindy Lim from Keppel Infrastructure Holdings will be sharing how to seize opportunities created by macro trends such as increasing interest in climate change, energy transition, and urbanization.
Good morning. Thanks for having me at this Tech Innovation 2021. Let me begin my presentation with an introduction on Keppel Infrastructure. Keppel Infrastructure is a wholly owned subsidiary of Keppel Corporation. Our goal in Keppel Infrastructure is to improve lives and the living environment by providing solutions for sustainable infrastructure. The business model of Keppel Infrastructure is development, investment, ownership, and long-term operationship of the critical sustainable infrastructure. In KI, or Keppel Infrastructure, we organize ourselves in 3 verticals, namely power and renewables, environment, and new energy. I shall not delve into details of these verticals. If you need more information about Keppel Infrastructure, please feel free to visit our website. Let me quickly jump into my main body of the address. I shall focus my keynote on 4 points regarding accelerating green and sustainable urban solutions, namely the key energy trends and perspective of the landscape in Southeast Asia in the coming years. Secondly, the opportunities and challenges to accelerate energy transition in Southeast Asia. Thirdly, the importance of open innovation and collaboration. And lastly, how do we humanize energy transition? First, key energy trends. Pre-COVID, rapid and massive urbanization and digitalization were already taking place. This has put unprecedented demand for energy and stresses on the environment. COVID-19 has only accentuated the needs for cities and industries to be cleaner and healthier. In the last 12 months, we also saw and hear bold climate goals commitment and acceleration in policies by governments, as well as mounting expectation on climate actions from the investors and communities. We see rapid advancement in clean tech, disruptive business model, as well as eco-partnerships. The convergence of these factors resulted in a highly transformative energy landscape, and this is what I coined by GREAT, G-R-E-A-T. What is GREAT? Firstly, the landscape will be greener, powered by more renewable and low carbon fuels. Secondly, we'll see more resilient supply and more reliable grid, where intermittency issues are substantially resolved with better storage of energy, better demand response management, and more importantly, more interconnection of energy system regionally as well as globally. E is for electrification and energy efficiency. We will see widespread adoption across sectors, and this become mainstream decarb means. A for better accessibility to lower carbon energy sources best suited for respective applications and sectors. With better accessibility, this will also drive better affordability. Lastly, T, technology will be the force multiplier of changes and movement. We will see prolific integration of innovative clean tech and low carbon infrastructure with proven best available technologies. There will be multiple pathways to decarbonization. This brings me to my second point, the importance of collaboration. The second point, the opportunity and challenges to accelerate energy transition. Now, in ASEAN, the population will increase pretty dramatically. In 2030. We'll foresee to have 717 million of people. And the aggregate economy is one of the fastest growing in the world, with a projected growth of 7.2% in 2021 and 5.4% in 2022. Climate change is a long-standing priority in ASEAN blueprints. And collectively, at the regional level, ASEAN leaders have regularly issued joint statements and commitments with regards to climate change. Specifically on renewable energy, ASEAN has set an energy efficient target of more than 20% by 2020 compared to 2005. And ASEAN has actually exceeded this set target. Besides energy intensity, it has also set a target to achieve 23% share of renewable energy in the total primary energy supply by 2025. What does this mean? This would equate to almost 35 gigawatt to 40 gigawatt of renewable capacity to be added by 2025. These are the opportunities. However, there are also huge challenges. Namely, ASEAN currently releases about 1.5 billion tons of CO2 to the atmosphere every year. This is greater than the greenhouse gas emission in Japan or Germany. Also, coal is a significant source of fuel for ASEAN. And ASEAN is the only region in the world where coal is expected to increase its share of energy mix, with close to 20 gigawatt of new coal-fired generation capacity under construction currently. If this trend continues, coal will account for nearly 50% of ASEAN projected 2.4 billion tons of CO2 emission in 2040. To this end, the linchpin for energy transition and decarbonization in ASEAN ought to be collaboration and open innovation. There are two specific areas that will exemplify the power of collaboration and open innovation, namely the ASEAN power grid and the alternative low carbon fuel such as hydrogen. On the note of collaboration and open innovation, the ASEAN power grid is an initiative to connect the region, initially cross-border bilateral terms, and then gradually expanding to sub-regional level, and finally to a total integrated Southeast Asia power grid system. Nearer to home in Singapore, due to land constraint and renewable disadvantaged terrain, the government has identified energy reset as one of the pillars under the SG Green Plan 2030. Under energy reset, there are 4 switches of energy. First switch being natural gas, which is the cleanest form of fossil fuel. This will continue to be the dominant fuel for Singapore electricity generation in the foreseeable future. The second switch is solar. It is the most promising renewable energy source for Singapore, and Singapore will quadruple our PV generation. The third switch is how do we develop regional power grids for cost competitive and low carbon energy? And lastly, the fourth switch is the exploring of emerging low carbon solutions such as carbon capture, low carbon hydrogen, and the utilization and storage of the carbon captured. The Laos, Thailand, Malaysia, Singapore Power Integration Project is one example of cross-border power trade in the region. The project has the ability to enable 400 megawatt of power transfer from LTMS PIP via cross-border power trade. And to accelerate ASEAN power grid, more alignment and actions must be put in place. The second bullet point on a low carbon alternative includes adopting CCUS and low carbon hydrogen as a key thrust under the Singapore government's decarbonisation plan. There are few pathways for CCUS. They are at technology advanced stage, but will still require further development to be commercially viable. And low carbon hydrogen is a key technology for Singapore to decarbonize our Jurong Island. And therefore, the collaboration and partnership opportunities are vast. We have to use collaboration and open innovation to catalyze innovative solutions, new business models, maximize value creation, incentivize investment, and lastly, to also minimize any dislocation of sectors or stranded assets and displaced workforce. On this note of workforce, I'll bring us to the fourth bullet point on humanizing energy transition. Now, ASEAN has a very diverse demographics. Population size also ranges from a very small 500,000 in Brunei to as large as 270 million in Indonesia. In terms of GDP per capita, we are also very diverse. We have 75,000 USD GDP per capita in Singapore and approximately USD 2,000 in Cambodia and Myanmar. So the top priority as we accelerate energy transition is not to forget the 3 A's. We must support the population through energy transition via, first A, raising the awareness and the impact of the transition towards green economy. Secondly, helping the population adapt to the changes in the processes, tools, and techniques. And the third A is to make green jobs opportunity accessible to a wider and diverse group of needs and aspiration. We need to believe that every worker can be a green worker. Modern days jobs are technology driven and knowledge-based. So I do believe that key skill sets can be and are transferable. So workforce transformation to remain relevant has actually already started pre-COVID. The pandemic has actually simply accelerated the need for workforce to modernize at a much larger scale and prepare ourselves to ride the energy transition opportunities. Mindset is the most important. So on this note, I'm very happy and bullish and hopeful that energy transition in Southeast Asia will bring about better prosperity and progress. I wish you all a very happy, fruitful forum ahead. Thank you.
Thank you, Cindy. Next, we have Frank Phuan from Sunseap Group, who will show how solar power has the potential to create a sustainable future in solar-dense or land-scarce cities like Singapore.
Good morning, everyone. Today, I'm going to share about the 4 switches of energy switch in Singapore. I think from the earlier speaker, Cindy, have already shared a little bit about this, but I'll go a little bit deeper on regional power grids and solar. So as you already know, natural gas is powering more than 95% of Singapore's current energy mix. But what if I tell you there is ambitions from the Singapore government to have this natural gas, this 95% of what is powering us today, to dwindle to 0 in 30 years' time? Is it even possible? Can you even think of how that can happen? Where Singapore is actually a natural gas hub, right? A natural oil and gas hub around the region. I believe so. And very much of how we can do so rely on the other switches that we see here today. So just going into solar. So solar is one of our very few, in fact, probably the only natural resource that we have in Singapore. According to the solar roadmap done by Ceres, the Solar Energy Research Institute of Singapore, we have the potential utilizing all sorts of horizontal and vertical areas in Singapore to achieve up to 8.6 gigawatts of power. All right, solar energy. What is 8.6 gigawatt peak of solar energy by 2050? I think this by no means is a limitation. You know, the 8.6 is not a limitation per se. In fact, this study has not considered the refreshing of technology, because technology improves year after year. The efficiency of panels improves. The same size panel, right, a 2x1 meter panel that is today is almost 30% more power, right, contains more power and more energy efficient than the panel, the same size, solar panel of the same size 10 years ago. So if you consider this refreshing, I personally believe that you can go towards a 10 gigawatt, right, towards a 10 gigawatt or more in Singapore. This is, of course, you have to consider all sorts of horizontal and vertical areas. So what do I mean by horizontal and vertical areas? I think in terms of horizontal, we are very familiar. All the rooftops, right? We are beginning to do solar on water surfaces. Water surfaces not only including your reservoirs, but also on the nearby coastal waters, where you can install solar systems and generate more power because of the benefit of the evaporation that will cool down the panels and generate more power. All right, I think it's actually mutually beneficial. It will also help us retain more water in our reservoirs because of the reduced rate of evaporation from the solar panels on the reservoir. I think looking at other horizontal areas like possible solar islands, right, nearby offshore islands, we are actually looking at projects around Singapore, near the offshore islands, where we can, instead of think of it as instead of land reclamation, you are expanding the island with solar panels, right? And then that itself is actually what I describe as a solar island. So those are additional areas that we can tap on. What about vertical surfaces? Vertical surfaces, I would say, if you look into a typical one, like what we call a BIPV, or building integrated photovoltaic, or vertical facade of a building. We have many buildings here in Singapore, right? Can we actually have solar facades of building instead of painting a wall every 10 years, which is a rule in Singapore? Can we have a facade now that generates power for us, right, over the next 20, 30 years? What about solar fencing as another vertical form of solar deployment? So we are now researching into how we can position the solar panels, right, not horizontally facing the sun, but vertically, right, like a fence, where you have bifacial panels today. You can generate solar both sides, right, of the solar panel. Solar fencing, think about solar on the MRT tracks that we have, right, as some sort of sound barrier. Is that possible? I think it's very possible, right? So all that to look into 10 gigs and more in Singapore, all right, I think it's not a dream. It is already coming true. We have a target of 1.5 gigawatts by 2025 that's been announced. We have a further target of 2 gigawatts by 2030. I think we are still a long way, but I believe we can get there. It can only serve to accelerate. So I strongly believe today, if you have a horizontal surface in Singapore and you are not utilizing it, I think it's just we are wasting a natural resource. All right. Moving on, I think we talk about low carbon solutions as well. So I think under this umbrella of low carbon, there are many types of solutions that can be under this umbrella, right? In this picture, I depict a picture of the EV charging, right? So EV charging is a form of towards low carbon solutions, all right? Every car that you replace, every ICE car that you replace in Singapore for EV, you reduce 50% of the carbon footprint. Now, this number will be different depending on where you are. If you are in a country where the energy mix has a higher amount of fossil fuel, or for example, coal, all right, higher amount of carbon, so this percentage is not as high as 50%. All right, it's because Singapore has, I think, a few mix where it's, I think, largely dominated by natural gas, which is in a way, one of the cleanest form of fossil fuel, right? So you have almost half the carbon footprint every time you replace an IC car with an EV. And there are many other umbrellas, many other solutions under these umbrellas, right? For example, energy efficiency, I think is another very key way of how we can reduce our carbon footprint. So to do energy efficiency, we first have to be able to measure them, right? So hence this whole concept of a smart nation, a smart building where you can have access to data, where you can extract consumption profiles of customers. Once you have that consumption profile, how does that data help you to identify peaks and spikes in consumption profile of our customers? And how do you reduce it using technology, right? Using, for example, energy storage solutions to reduce that spike, right? So I think batteries, ESS, come hand in hand together with our first switch of the solar switch as well. To proliferate solar, you need to proliferate more energy storage. So moving along to our last switch, which is regional power grids. I think this is really the subject that is trending this year in terms of the energy transition. We have long thought about the concept of ASEAN grid and ASEAN grid, right? But it has never materialized over the past few decades. But I believe today, with Singapore and Singapore's demand for clean energy, I think this will position Singapore in the front and center of the ASEAN grid. Why? Because there is a lot of demand, right, from the data centers that want to go green, from the RE100s, right? There are many customers who are insisting on green energy now. Now, looking at Singapore's own 10 gigawatt peak of deployment in the next 30 years is not going to be sufficient, right, to address this demand. In fact, our local government agencies, EMA, actually do forecast 1.5% to 2% increase on energy consumption year after year. You have more things that will rely on electricity, right, like your electric vehicles, right, and hopefully more data centers as well as to go with the digitization. And I think this demand for green energy will only increase. So what do we have now? We have almost 6,500 megawatt of power that we are consuming today. All that and beyond, when we talk about 1 to 2% increase year on year, by 30 years time, we are nearly doubling this capacity, right, to 13,000 megawatt. How do we replace all that with the first two switch? I think is not possible. All right, even if you fill up every surface area in Singapore in terms of horizontal and vertical, I don't think it's sufficient. So we need to rely on cross-border regional power grids. And I think the first trial between Malaysia and Singapore has been announced. Sunseap, we participated in the RFP that was conducted in June. All right, so fingers crossed that we get good results on that. I also believe there will be future calls for RFP from EMA with regards to cross-border. All right, just think about it in the region. We have access to many of these natural resources. For example, there are many areas, horizontal surfaces, islands in Indonesia that we can tap on nearby Batam, right? Just 1 month or 2 months ago, we have our company has also announced one of the world's largest floating solar system to be set up in Doron Reservoir in Batam, right? Now this will be not only the world's largest floating PV system, but it also contain the world's largest energy storage system at 4,000 megawatt hour and beyond. So really this whole system is to address the whole intermittency issue. Singapore wants to have green power, but not only green power, we want to have green and non-intermittent stable power. So what we are literally doing is we are going against the nature of solar to provide 24/7 day and night stable power. This will be a very exciting energy transition. So look at the chart below is our way of saying into the future 2050, we are peering into the crystal ball and say how this 100% decarbonization of our energy grid can be achieved. Just want to show a little picture of the floating PV project that we have in Singapore. All right. In fact, the picture that you see here on the right-hand side is Malaysia, the one with the buildings, right? The one with the greenery is actually Singapore. And if you look hard enough, right in ahead, you will see the causeway, the Woodlands Causeway. So it's very near to the causeway. So this project is a 5 megawatt demonstration project in the coastal waters. As far as I understand, today it is still one of the largest offshore or coastal water PV. There are many PVs, including the one in Sungai Tengah that is in the freshwater reservoir, but this is in the sea. All right. So there are many considerations when you talk about a floating PV in the sea, right? Because the platform or the floating PV is not only moving up and down according to the water depth, but it's moving left and right 360. So a lot of consideration with regards to mooring. So I believe we can tap on the marine industry that we have here in Singapore, all right, to do more of these coastal PV projects. Also, if you look at the bottom of the picture, you see a barge. The barge contains the transformer and also what we call a module. Above the transformer, there is the 40-foot container. This can be modularized, right? The module that we have used here is for a viewing gallery. So imagine if you want it to be a different purpose or application, like say, if you want it to be a military purpose, you can have a military module. If you want a residential module, you can have a residential module. I think the whole idea that we have is we are trying to illustrate, if you have sunshine, access to sunshine, if you have access to sunshine, you have access to power. And with that, you can live and work anywhere in the world with water and sunshine. All right. So I strongly believe that all this capability built up, all right, will drive us the next energy transition that we are seeing right now. I think in this generation, we're going to see the energy transition from a carbonized one to a decarbonized one, which is something that I would say the change is going to accelerate so much that we will find solar panels commonplace, right, in future. So I want to end off my presentation by saying that I think many times we think about solar panels outside of our view because they are usually on the rooftop or on a surface that we hardly have access to. But it's easier to think of them as planting trees, right? So every tree, every megawatt of solar panels that we install in Singapore, around Singapore, equates to roughly planting of 15,000 trees. So if you think about it that way, we can contribute by planting a lot of trees, all right? And by setting up solar systems around Singapore and around the region. So we'll encourage everybody to choose clean power and plant more trees. Thank you. Yeah.
Thank you very much, Frank. Now, as we will be moving on to the panel discussion segment of this keynote, we would like to encourage you to submit your questions in the Q&A feature on your screen. Professor Subodh Mhaisalkar, Executive Director of the Energy Research Institute at NTU, will be the moderator for this panel discussion. We will invite our speakers back on screen as well.
Thank you, Alvin. So as Alvin was mentioning, there are several questions coming in for the panel discussion on the websites. But what I want to kick off with is something that Cindy mentioned. And Cindy mentioned the role of, the growth of ASEAN. As most of us know, ASEAN will see very significant population growth as well as the growth for demand of energy. The fastest growth region in the world actually is going to be ASEAN in terms of emissions. So I have a question both for Frank as well as for Cindy. So let me start off with Frank first. So from an ASEAN perspective, what are the opportunities for renewables that ASEAN can tap on beyond solar?
Sure. I think the region is, like I mentioned earlier, full of natural resources, right? If you look at Laos, if you look at Sarawak or East Malaysia, there's plenty of hydropower. And many of this hydropower, they are actually over capacity. So there's an overcapacity situation. So it's really an unbalanced way, if you think about it, that you have over excess of power in some regions, and some regions like Singapore in dire need of green energy. All right. So I think we can tap on hydro, and the same is likewise for offshore wind as well. Offshore wind is still very new in Asia or ASEAN. I think we do see some markets beginning to tap on offshore wind. So other than solar, there are many others. I think geothermal is another very underdeveloped resource in the region. I think a lot more can be done in Indonesia and Malaysia for geothermal as well. But I think the more important thing that is driving all this development of clean energy projects will be the demand. So I mentioned Singapore has that ambition to do so, and I'm pretty sure the government probably will announce something soon. All right, but yes, just yesterday, Malaysia have announced 2050. They want to be completely carbon free in terms of their energy mix. Right, so I think all these ambitions from government and expressions of decarbonization will surely drive the development of clean energy projects around the region. Yeah.
Thank you, Frank. Cindy, from your perspective, what would be the priority areas for countries like Malaysia, Indonesia, Philippines, Thailand, which will contribute to 90% of the emissions of the region? What can these countries do in terms of reducing the carbon emissions?
You know, I always like to draw a parallel to the safety hierarchy. And just like safety hierarchy, the first most efficient and intuitive means should be elimination. So I think for the carbon emission in ASEAN, especially countries who are very dependent on coal and oil, I think one of the immediate tasks could be switching out to a cleaner source instead of frog leaping into renewable or low carbon alternative. Maybe as a form of transition, gas as the cleanest source of fossil fuel could be an option. That's but just one aspect. And I truly also believe that all existing installed infrastructure, there should be a relentless effort on improving energy efficiency of current installed and matured and operating assets. So this too will be the key mainstream. Then of course, where possible at the end use, push for electrification. So instead of direct combustion for heating, for cooking users, or for even, like I said, vehicle, switch to electrification. Now that is but just means and pathway. And I also believe in terms of behavior, the social and human behavior has to be also upgraded in terms of people's view and approach towards emission, towards combustion, towards primary energy sources. So I think these are force multiplier before we even talk about very advanced technology. These are very low hanging fruit with already matured and proven technology that we can latch on.
Great. Thank you, Cindy. So Cindy did focus up, some of her points on electrification. So there's a question that has come on from our audience, and this is relating to smart grid systems. Does any one of you want to take that question and address what are the changes needed to our grid infrastructure to really accommodate both from a renewables perspective as well as electrification?
Sure, I'll give a shot. I think that smart grid, the whole concept of smart grid is really to be, the grid must be flexible enough to allow that intermittency of the renewables to come in, right? I think to me, the grid has one role, really to balance between the supply and the demand and perform that distribution, right? And if the supply is intermittent, right, and the demand is not, how do you allow for that to happen? As we see more and more solar comes into, let's say, taking Singapore example as an example, we have one of the world's best grid, right? Resilience. There are so many layers of redundancy, right? And we have an over power capacity. So that allow a higher tolerance of intermittency. But having said that tolerance has a limit, right? So we did do some work together with SP and EMA before, in order to explore the power quality, right, of the Singapore grid in terms of frequency, right? So if there is a frequency adjustment, there will be a frequency adjustment, all right, which affects the power quality if we see too much intermittency being introduced to the system. So the answer to that is, how do you address that intermittency is, I guess, is energy storage. So I feel that the future grid or smart grid will have to incorporate, right, distributed sources, distributed ESS, and centralized sources and centralized ESS, right? So it will be a mixture of all this. So there is already a concept of a nano grid on. Even think about the possibility of, there's a moratorium on data centers now. And the only way to overcome that moratorium for new license of data is to go off-grid. So I think it's hard to imagine an off-grid data center. But if you think about the various sources of whether is it renewables or fuel cells, hydrogen fuel cells, that makes it possible. Then how do you use the grid as a backup to this off-grid data center, or the other way around, right? How do you use the fuel cells as a backup to the data center, which is then tied to the grid, right? All these various sources of various intermittent and distributed sources. I think the future of grid is about incorporating all this together. Yeah.
Great. Thank you, Frank. Perhaps Cindy, I can approach you for a couple of other questions that have come in. And this is right down your alley, given that you are into power generation as well. One of the questions that has come up is, how about biomass? How does biomass or bioenergy feature in this? And if you can touch upon biofuels, that will be great as well. And a related question has come in from a hydrogen perspective as well. So from a fuel mix perspective, can you comment on bioenergy, and from a long-term perspective, hydrogen too?
Certainly, thank you. We have been in the waste to energy business for more than 20 years. And if I were to unpack the entire value chain of waste to energy, the challenge is not in the technology itself. It is a very proven technology to convert incoming domestic solid waste or biomass to that of electricity or power. The challenges actually lies in two things: the upstream, whether there is efficient and coordinated ways to collect the waste or the bio waste sources. So whether there's a collection system, that's number one. And secondly is the competing resource. In this case, landfilling cost is always way cheaper than the tipping fee to a waste to energy facility. So I truly believe that there must be political will to set a certain target to gradually transit from 100% landfilling to maybe gradual reduction, say for instance 85%, 65%. It's just like how we manage fuel mix transition. That it is always a transition of the mix, but there must be willingness and commitment to divert bio waste from landfill, and then how do we use it for a higher value add output, in this case electricity, for example. It could also be used for heating purposes. It doesn't necessarily need to be just electricity, but literally waste to power, whether it's for heating, whether it is for electrification. Now, that is the, hopefully I could answer that. Again, I'm very consistent. It will be the behavioral part of the population as well. How do we consume? How do we dispose? Because in Asia, especially when we look at the mix of the waste disposal, by in this case organic waste, has very high fraction. There's a lot of wastages when it comes to consumption, whether it is packaging, food, or I think waste that hasn't really reached the end of life. So the entire push towards circularity of products, of material, and of resources has to be reinforced. In terms of hydrogen, I do believe that it will take time, but it's certainly accelerating because we do feel a lot of traction in terms of awareness, willingness, and pre-investment coming into developing hydrogen as a potential primary source of energy carrier. But when I look at the whole decarbonization piece, I think renewable potentially take up 1/4 of the effort. Don't forget, maybe 20% of the effort should come from electrification, the other 20% from maybe, like I said, energy efficiency. Now, then that leaves us with maybe another 25% equally cut into bioenergy or biofuel, potentially hydrogen, and then CCUS for hard to abate sector. So this is how I roughly see the contribution of investment and effort should sit.
Great. Thank you, Cindy. A couple of questions coming in for Frank are relating again to deployment of solar as well as regional grids. So one of the questions is, are there any environmental concerns with floating solar? Can floating solar, I mean, success in Singapore, and can it be shared in the region? Are there any cost penalties? And a related question is, there's been a lot of talk about Australia supplying electricity directly to Singapore. So can you comment on that possibility vis-a-vis what we could do with the regional grids, please?
Sure. I think floating solar is definitely something here to stay, in my opinion. In terms of the environmental impact that the question was referring to, if you think about in the sea, right? Let's start from floating pontoons in the sea, because that was the project that we did. I think before we do any project, we always look into the environmental impact. So there is a study period that we need to start and give a report of the potential environment impact before we even start any construction. So for the particular one that we have done in Woodlands, I think the result, in short, is there is hardly any impact. But bearing in mind, we chose the site very carefully, right? In fact, we spent almost 2 years period interacting with the various agencies to identify a particular location that will result in minimal or no impact. We have to avoid all forms of mangrove swamps or mangrove areas, all sorts of leisure, right? And as water sports leisure activities, and all sorts of avoidance of any form of impact towards specific location that may have an impact on aquatic life. So the material that we use for the floating pontoons is not different from those mobile jetties, all right? If you look into some of the kelongs that we have, or if you go to some resorts, you will see when you arrive at the resort on the beach, there is this mobile jetty. It's the same material, polyethylene, right? And that material, we have make sure we do plenty of testing in the lab prior to having them at site to be deployed. I think the same goes for the deployment for solar in the reservoir as well. In the reservoir, the material polyethylene is tested against drinking water to look at the amount of dissolved oxygen. We are talking about tons of parameters that we are testing, right? Even before we get to a stage where we can even deploy them. And those have to, again, pass all sorts of standards that's instituted by the local agencies, in this case, PUB. I think it has shown that there's very minimal results. One of the more, I think, key parameter that we want to take note of, though, is the coverage, total coverage of the solar panels in terms of the surface area in the reservoir. If it's too high, and there is a certain limit, if it's too high, then it may cause a slight, very, very slight temperature increase in the reservoir, right? We're talking about point something degrees, right? Those more of those effects need to be studied as well. But so I guess it is always a balance, right? When we talk about the need to look for area, and in this case, horizontal area, floating PV is definitely here to stay. All right, there are deployments of many floating PV, not only in reservoir, but in hydro dams. You think about them in hydro dams. These are untapped, unused areas previously, right? In a lot of irrigation reservoirs, like I mentioned earlier, we can actually help to retain the water in the reservoir, thereby keeping the purpose of the irrigation reservoir to have more water, right? The other question regarding, I think it was specifically
in very brief, please.
Yeah.
Importing from Australia versus ASEAN.
Yes, from Sunseap, right? I believe that project has its own set of political and technical challenges. I think 4,500 kilometers from is certainly a long way. It's like from China to Singapore, but on land. But now we are doing it in water, so it's certainly not easy. But it has been approvals that we've seen in news that the Indonesian government has already approved the transmission. I guess the details, the devil is really in the details in terms of the more study to be done on the transmission cable and how that will heat up the ocean, right, as it passes, because we are talking about transmission very high power. Thanks, Frank. We are running out of time, so I have one last question to open up to both of you. Let's look at 2050. I think globally there's ambition towards net zero. So can you very quickly summarize what are the changes needed in policy, technology, human behavior, new technologies which are yet to be announced that will allow Singapore and ASEAN to hit net zero by 2050? Perhaps Frank could go first, and we'll ask Cindy to wrap it up. Thanks. I think that we will see the introduction of carbon tax, right, and more severe carbon tax as we realize that there is a true cost of operation, and the true cost that we see in many industries today do not incorporate that tax. So that tax can come in different forms, right? Whether is it a carbon tax or a grant being given, all right, or incentive being given to the green energy portion. So I see that happening. I see more smart meters and sensors being deployed around the cities, right, to tap on data and the consumption profile of buildings and customers. Once you have data, then you can do something about how to address the energy consumption. So I think ultimately is I believe that the pandemic has really taught us about sustainability and our supply chain vulnerability, right? So a lot on security, energy security, emphasis on energy security, as well as how we can get greener sources. All right, that is already in the mindshare of governments and people around the world. Thank you, Frank. Cindy, you have the last word. Tell us what needs to be done by 2050, please.
I think this future back, going to the future and looking back question is a very powerful and empowering one. If you look at it, 2050 is not far out. It's 30 years later only. And 30 years ago, it was 1990. If you were to draw a comparison, 1990 versus 2020, what we saw is really the transition from oil to from movement of oil to movement of natural gas by liquefaction. So as a result, you see there's a lot of growth in economy, powering knowledge-based sector in particular, such as data center, technology, proliferation. So I have suspect by 2050, you'll see the same democratization of the use of renewable through more interconnected grid, the use of more renewable through shipment of green molecules, hydrogen in whatever form of carrier. And I think behavior-wise, you see more ownership and accountability in terms of environment impact in the location or in the scope of work or the living environment that people engage their work, live, play in. And I have suspect it will be more distributed digital, and the keyword is small being beautiful. So you have a lot of more self-sufficient towns and cities and producer who are consumer. So you see a lot of prosumer and a lot of interconnected accountability. To your point about what will facilitate this, I think leaders of the world, whether commercial leaders, industry leaders, political leaders, ought to believe that the shared goal can only be achieved if people balance risk and reward and balance pros and cons at the integrated level at a global scale, rather than to optimize at a bilat and an individual level.
Thank you, Cindy. That was a perfect summation of all the challenges and solutions we have. Again, I want to thank Frank and Cindy for this very informative session and sharing your vision for making the world a better place. Thank you all. Bye-bye.
Thank you, Cindy, Frank, and Professor Subodh for the exciting discussion. We've come to the end of the keynote session on powering a green and sustainable future today. Thank you to our speakers and to all attending this webinar for your active participation. We hope that you have benefited from the insightful presentations. Please click on the info button on your screen to submit a rating out of 5 stars and your feedback before exiting the session or joining the next one. For attendees who will be joining us at our next keynote session on designing a sustainable future for our planet, we'll see you after the short break at 11 a.m. Singapore time. Thank you once again.